I understand the problems. All right. Yes? Mr. Gross, no? Okay. 151. A rain gutter. I understand the problem very well. I hope. A rain gutter is made from sheets of aluminum that are 20 inches wide. As shown in the figure, the edges are turned up to form right angles, okay? And they even give us a little diagram here, okay? Determine the depth of the gutter that will allow a cross-sectional area of 13 square inches. Show that there are two different solutions to the problem. Round to the nearest tenth of an inch. Okay? So this rain gutter from the front view is going to end up looking like this after it's been folded up. And they even give us, they say that's x, and that's 20 minus 2x. Raise your hand if you don't understand this part. That's why this is 20 minus 2x. No one's raising their hand. Everyone's struggling, but we're good with this. Yeah. Okay, that's fine. All right, that's good.
Wait.
What?
Why is it different if it's a perfect square? This is a perfect square.
What is a perfect square?
That square.
What square?
The one you're drawing.
I'm on number 151. So here's where I'm gonna get you guys eventually. It might take some time, and I know these are challenging. We're gonna take a word problem. We're gonna make a visual if it's not already provided. We're gonna understand what's going on. We're gonna write some statements mathematically, and then the math will do the work for us. But getting there, the math language, that's where we have to get. So far, this should make sense that if I add x plus 20 minus 2x plus x, it better be 20. Because they tell me that the rain gutter is made from sheets of aluminum that are 20 inches wide. And this is a front view. I'm looking down the gutter, so this is a front view. Okay. Determine the depth of the gutter that will allow a cross-sectional area of 13 square inches. X is the depth. And maybe some of you didn't realize that. They set it up for you. They purposely would set it up. They're going to let the variable represent what you want to find. So they made it convenient. There were no tricks involved in this problem in the sense that X is what you will solve for. Because you have no idea, if you think about this as the depth, you have no idea. Right? So they're not talking about that depth. They're talking about depth like this. Okay, all right, so you got that. So, but that's helped some people, okay? So now the next part is probably the most confusing part. Is this cross-sectional area of 13 square inches. They're not talking about volume. Okay, so toss that out the window. How could I cut this so that I would have a fixed cross-sectional area of 13 square inches wherever I cut it? Would I cut it like this? Or would I cut it like this? This is the part you have to visualize. You have no idea about the length of this gutter. We have no information on that. So it makes no sense to even think about that face of the gutter. You only know this. So it would have to be cut like this. It would have to. So when it's cut, we want to know what the area of this is. Even though there's no top, it should not affect the area. So we want to find, actually we don't want to find it, we know what this is. They tell us what this is. All right, that's this, right here. They say the area of this is what? 13 square inches? This is 13 square inches. So this is where now you have to pull something from your past. What's that?
I don't understand what base is that.
This is looking at this right now.
It's the same front view,
Mm-hmm.
and they're saying that that's, they're saying the area is 13.
That's what it says, 13 square inches, yeah. Yeah, because we have no idea about the length of this gutter. We know nothing about it, so it makes no sense to even think about cutting the gutter a long ways.
Can you read it to me? What Quadratic I see something?
Determine the depth of the gutter, which is X, that will allow a cross-sectional area of 13 square inches.
I guess the
Cross-sectional term?
Confused there, but I thought it was gonna be like a little line and it was gonna be like something, but you're just saying that the front, thing there is
You gotta make 13 inches fit into.
Yeah, cross-sectional area. If I cut it across, yeah. Okay, and again, we already have these as, we know this is X, and this is 20 minus 2X. So now, we have to think about pulling something from our past. Do we know the area formula for a rectangle?
BH and a half, something like that. B times H and a half.
Take off the and a half.
Oh, B times H.
Base times height.
Yeah.
Base times the height would give you the area. You might also know it as length times width would give you the area, whatever you want to call it. Base times height, length times width, means the same thing. So we know that, so let's write that, because that's something that you guys should know the area of a rectangle. I think we'd all agree on that. Area of a rectangle is length times width or base times height, whatever you want to write. The length is 20 minus 2x, the width is x. The area is given too, so now I'm going to substitute 13 into area. The length is 20 minus 2x. And the width is x.
If I was
I was just saying, like, if I was knowing, I would know what to do.
I think the toughest part about these problems is being able to visualize it. Once you get to here, a lot of you might say, okay, I know how to solve a quadratic. But let's continue on with this. So now, if we find x, we're done, because that's the depth. So going from here, you guys know we need to set it equal to 0. So first we need to distribute. So we have 20x minus 2x squared. Bring the 13 over, so 0 equals negative 2x squared. I'm just rearranging it, which you're allowed to do, of course. Order doesn't matter for addition. Minus 13. Subtracting 13 from both sides.
I don't have it like that, but I put like one more X in it.
Okay. Be careful. Is this fully simplified?
No,
Wait, yeah.
Yeah, this is fully simplified. There's no like terms. Here's an x squared term, here's an x term, here's a constant. It's as fully simplified as it gets. Now we should recognize that it's a quadratic. And you may recognize it up here, because you can tell that when you have an x times another x, it's going to be x squared, but definitely a quadratic, yes? So when it says that we're going to round our value, I already know we have to use the quadratic formula. I know that trying to solve this by factoring is not going to work, because they even say round to the nearest tenth of an inch. Do we need to see the rest of this quadratic formula? Or are you guys good? Was this the tough part, setting this up to here?
Okay. No, we don't need to.
Raise your hand if you do want to see it, the rest. Okay, so we'll go from here. So we're going to go edit, copy. This is 151 continued. And edit, paste. What's that? What can you hear me? This thing? No, I don't think you can hear me. But the microphone on my laptop can hear
That's
me.
what I'm saying. So in the recording, I need
Yep. All right, so the quadratic formula, we say x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to negative 20 plus or minus the square root of, sorry to stand right in the way, 20 squared minus 4 times negative 2 times c of negative 13 all over 2 times negative 2. Not a bad idea to convert all this to addition. Like maybe make this plus negative 13 if it makes it more clear to know that c is negative 13, not positive 13. I'm going to shrink this. So going on from here, x would be equal to negative 20. Now, because I know I'm going to go ahead and round anyway, but you know what, since we're here, let's review how to simplify it and leave it in perfect form, you know, and then we'll go ahead and punch in the calculator. So someone with a calculator, by the way, good news, if you guys want to borrow a calculator during class, I picked some up. They had some in the storage. Just make sure when you're done, go ahead and just return it. Okay, so make sure you go ahead and just return it back in the box. For those of you that don't have a calculator. So I will probably be using that one. You guys are in advanced topics. I would still probably recommend getting a scientific calculator that lets you punch in a parentheses, a val. You can see everything you're punching in and then close the parentheses. Yes.
That's what I was going to ask you. How do you put the quadratic equation into the calculator? Like, would you do it like that with the minus,
Well, I'm going to clean this up first. I'll plug it at the very end. At the very end, I'll do that. So we'll say that's at the end. So here we have, what, 400. Now, here's where a simple mistake can be made. We're going to avoid that simple mistake. I have minus 4 times negative 2 times negative 13. Well, how many negatives do I have here? 3. So it's going to be a minus, and then just focus on the absolute value. 8 times 13, 104, I think. Negative 4. And then continuing from here, x would be equal to negative 20 plus or minus the square root. 400 minus 104 should be 296 all over negative 4. So x is equal to negative 20 plus or minus this here. If you guys remember how to simplify this, you can do it using prime factorization. Which is probably something that we'll quickly review that now. So I have 2.
When we divide the denominator and then what's called.
So prime factorization is breaking a number up into its prime components. So 296 divided by 2 is 148. And I keep doing this, right? Okay, 2 and I'll keep doing the smallest prime number, which is 2. And it breaks down pretty quickly. And I get down to 37. So if I want to, so the square root of 296 is going to be equal to, I can take out a 2, and what's left underneath is the 74. So this is the simplified version of that. What's great about this is regardless of the index, which here it's 2, it's a square root. If it were the, while we're here, if it were the cube root of 296, you could circle 3 2s, and this 37 would be left over. So you'd have 2 cube root, what's left underneath? Sad looking 3. Cube root of 37. So this is a very convenient tool. Don't think it just only works for square roots. It works no matter what the index is, as long as it's a positive whole number.
And what's that called?
Prime factorization. Yeah, so if you guys want to look this up some other time, I'll go ahead and write. I'm definitely going to go back. So we have, this is called prime factorization. So we got 2 root 74. All over -4. And then here, this is when it can go one step further, because as simplified as you can get, each of these has in common what, -2. So if I divide out -2 from the top and the bottom, I would have 10 plus or minus root 74 all over +2. You guys see that? Just divide out -2 from the top and the bottom. So this is my answer, but they want you to round it, so then you just punch in the calculator. And I think they told us that there would be 2, or there may be 2. Show that there are 2 different solutions. Okay? Can we have a negative depth in reality? No. So both of these better be positive. Whether I do 10, when I'm punching 10 plus root 74 over 2, and when I do 10 minus root 74 over 2, they both better be positive. Otherwise, the book lied. Or I made a mistake. 10 plus root 74 is whatever, divided by 2 is approximately 9.3. So the approximation's been using the calculator. So I want to shrink this up a little bit. I want it all on one screen here. Just a little bit. Let's see if we can do that. That works. So the 2 solutions, x is approximately 9.3. And it was this feet? Yeah, this is, no, inches. Yeah, 9.3 inches is 1. And then if I go back up, and this is where if you have a scientific calculator, it's so nice to just go back up to the line that you did, and you can change it from a plus sign to a minus sign. This calculator is a little different. Round to the 10th. Yeah, so 0.7. So here are the solutions that they're looking for. They end up both being positive. Otherwise, it wouldn't have made sense because they told me there were 2 solutions. If one was positive and one was negative, or both were negative, I'd be like, wait a second. They told me there's 2 solutions. So this rain gutter could be 9.3 inches deep, or it could be 0.7 inches deep. Think about the different rectangles that you can have. Yes. What's that? The other page? Here? The prime factorization? Yeah. What's that? Yeah, you guys are more than welcome to come see me. I'll be here 3:45 to 5.
Oh, man, that's right.
All right, any other questions about this problem? Did this make it a lot more clear?
Yes.
Okay. Was it less difficult than maybe you thought?
Yeah.
Was the toughest part the cross-sectional area?
Yes.
Yeah, cross-sectional. Like if I have something that's this in length, cross-sectional is like cut it this way, and you look at it.
It's diagonal.
It's diagonal. No, if I just have like a flat, if I take this thing and I want a cross-sectional area, well, it's going to be the area of that right there, that small little rectangle.
Oh, that's what it is?
No matter where I slice it, it's going to be the same. No matter where I slice it, it's going to be the same rectangle, right? There was no mention of volume, so you know you weren't dealing with volume. And you had to recall previous knowledge. You had to recall, I know the area of any rectangle is length times width, and then the things should have come together.
And I was like confused on like what the whole cross sectional area, like where to like do the cross section now, like where to cut it from. Like, oh Lord, that was hard.
Okay. Next one we have is number 152. Same page. All right, I'm going to read it out loud. It says a piece of wire. A piece of wire is 8 inches long. The wire is cut into 2 pieces, and then each piece is bent into a square. Find the length of each piece if the sum of the areas of these squares is to be 2 square inches. Wire. And it's cut here. And they tell us that they're actually nice enough to give you the diagram. You'll eventually work on word problems. You'll just have words. Those are going to be a little bit tougher, but that's why you got to be able to have the ability to put something on paper. Say that's x. This would have to be 8 minus x because the whole thing is 8. So I'll read when I do these problems, I'll read them more than once. I got to soak it in. I'll read them 2 or 3 times, 4 times if I have to. A piece of wire is 8 inches long. Okay, I get that. So this whole thing is 8 inches long. The wire is cut into 2 pieces, and then each piece is bent into a square. Find the length of each piece if the sum of the areas of these squares is to be 2 square inches. Okay, so I take this piece, I bend it into a square. I take this piece, I bend it into a square. What do we know about the side lengths of a square? They're all the same. Okay, good. And they were kind enough to actually give you that as well. They tell us they actually did it for you. But let me know if this doesn't make sense as to why this is x over 4 each side. Let me know if this doesn't make sense. It doesn't? Because you're taking, that's from this piece. So this here is taken from here. This piece was bent into a square. Well, the whole distance, the perimeter has to be x, but because it's a square, you need to, divide it out 4 because they each have to be equal. So it'd be x over 4 for each side. And the other guy, you're taking that and dividing it by 4. So even though it might look weird, it's technically going to be 8 minus x over 4 for each side. This is the bigger square. Okay, so here's the big sentence. Find the length of each piece if the sum of the areas of these squares is to be 2 square inches. So we want to find, eventually this is what we want to find. Find what's circled in red. Okay? If the sum of the areas, do we know the area formula for a square? Base times height, or more specific for a square, is simply what? Length squared, or s squared. You'll sometimes see it as s means the side length. So we know that the area of any square is just s squared. So this is coming from this is like the previous knowledge aspect, similar to the last problem we did where you had to know the area of the rectangle is length times width, or base times height. What does sum mean? Addition, yep. Okay, so let's do this. So the area of this guy would be what? If I take a side length squared, well, I'm going to do that exact thing. X over 4 squared. That's the area of this one. The area of this guy, same formula, the side length squared is going to be 8 minus x over 4 squared. And they say that the sum of these areas must be 2 square inches. I'm about to go on the next page. Actually, unless I can, I don't want to check it now. Okay, I'll go on the next page. This is 1, 2, 2. So the total area is going to be equal to the area of, we'll say, the small square plus the area of the large square. You guys can use whatever notation you want, whatever makes it straightforward. This has to be what?
2.
It has to be 2. Needs to equal, area of the small square is x over 4 squared plus 8 minus x over 4. Yes? All right. So let's keep working this out.
I can't see.
You guys know how to do this, right? So 2, my God, undo that size right there. So 2 equals, if I square this, what I have? Thank you. And if I squared this, and we'll leave it right now, we'll leave it as 8 minus x. 8 minus x squared over 16. We're allowed to multiply both sides of the equation by whatever value we choose. That's a constant besides 0, about an equivalent equation. I don't like fractions. I'm assuming you guys also are not fond of fractions. So I'm going to multiply this whole equation, or each side of it, by 16. So that's the least common denominator. So I would have 32 is equal to x squared plus 8 minus x squared. Now, we will continue with these problems tomorrow, but do you guys want for me to keep working on this problem, or do you guys know how to do it from here? Keep working on this one? Okay. So if I keep going, then 32 would be equal to this guy expanded. If you forget the formula for expanding a binomial when it's squared, then just do it the long way. Actually write out 8 minus x times 8 minus x. But what it's going to end up being is going to be 64 minus 16x plus x squared. If you did a long way foiled, you would get that. All right. Does the right-hand side simplify at all?
Yes.
Yep. I'm going to take this and I'm going to push it over a little bit. I don't want to mess it up too much. Let's move it over. Whoa, that's weird. squared of 64 minus 2ab, negative 16x, plus b squared, and the x squared. Again, if you don't see this, just do it the long way. Because a lot of people forget how to do that. But if you yeah, the formula is, if you remember,
And you wouldn't do it against
if you have a plus b squared, that's equal to a squared plus 2ab plus b squared. But you don't have to, if you don't remember that, then just do it the long way. Do FOIL. Alright, so let's continue on. We have time. Ooh, bell's about to ring any second. But you guys should probably know from here, simplifying, set equal to 0, quadratic formula. This is quadratic.